All right, so y'all go ahead and do the factoring and the math knowledge question for today, and then unpause this video once everyone has finished, and you can check your answer with mine. So this is a factoring by grouping. We're going to factor these two. We're going to factor these two. So the first two have an x to the fourth in common. And if you factor that out, you're left with x squared plus 2. And then the second two have a negative 16 in common. And if you factor this out, you have an x squared plus 2 left. And so we talked about this within the last week or two. You will rewrite this as x to the fourth minus 16 and then x squared plus 2. So that's factoring by grouping. However, this x to the fourth minus 16 is a difference of squares, and it'll factor further. It'll factor as x squared minus 4 and x squared plus 4. And we have the times x squared plus 2. But if you look, this x squared minus 4 will factor yet again. It's again a difference of squares. So we would have x minus 2 times x plus 2, and then we have the x squared plus 4 and the x squared plus 2. And so all of this right here would be your answer. Moving on to the math knowledge question. The measure of angle y is 50 degrees. So we have 50 degrees here. This is a parallelogram, so that means that this angle here is also 50. And it asks for the measure of the angle between y, or wx, and the y-axis. So this angle here. Well, we know that this is a right angle because our x and y-axis are perpendicular. So if this angle is 50, that means that this angle here is 40. And so our correct answer would be B. Okay, so we are looking at lesson 72 today. We're looking at derivatives of a to the x, where a is a number. We're looking at the derivative of log base a of x, and then also the derivatives of the absolute value of x. So hopefully you'll understand these derivatives after the lesson today. The first two, you have a formula for it. The derivative of a to the x is the ln of a times a to the x. And so that's the formula. You do need to learn it. You'll have to be able to use that formula to be able to draw these. Okay, so let's look at an example where we use that formula. We have 17 to the x, and we want to take the derivative of our function. Well, our formula is just, the derivative is the ln of our base number, which is 17, and then multiply that by 17 to the x. And so this right here would be your answer. You're just using your formula there. Okay? Let's look at another one. We want to find the derivative of our function y equals 42 to the x squared minus 5x. So this one again, we're going to use our formula. The derivative is going to be the ln of our 42, and then times 42 to the x squared minus 5x. But that's not the final answer, because we also have this x squared minus 5x. That's kind of like a 42 to the u. And so we actually have to take the derivative of the x squared minus 5x. And the derivative of that would be 2x minus 5. And so once you have that, then you've got your entire answer. So all of that would be the derivative for that function. Okay, let's look at this one. So this is like a cosine of u. And so we're going to take the derivative. So the derivative of cosine is negative sine 14 to the x. And so we took the derivative of cosine. But now we have to take the derivative of this part that's inside, the 14 to the x. The derivative of that is going to be ln of 14, and then times 14 to the x. And now that you've taken the derivative, this whole thing would be your answer. Okay, so those are some examples of how you take the derivative of a number raised to an x. Now we're going to look at taking the derivative of log base a of x. So this is the formula. log base a of x equals 1 over x ln of a. I don't have a song or anything for you to learn this one with, unfortunately. You just have to learn. The log a turns into an ln of a, and the x goes in front. It's a lovely formula, but it's very useful on the AP test. So you definitely want to make sure to learn that. So it becomes 1 over x ln of a. So let's look here. To take the derivative, we're going to have 1 over this x goes in front, and then we have the ln of the base, which was 42. So we have 1 over x ln of 42. And then we're going to do the same thing here. We have 1 over x ln of the base, which is 10. And so this is where I would leave my answer. However, sometimes your answer key is going to factor out the 1 over x, and it's going to write it like this. And if you want to write it like that, that's fine. Sometimes they may simplify it like that, but you certainly don't have to do that. But either one of those is perfectly acceptable for your answer. Okay, so let's look at the next one. It gives us a function, and it wants us to approximate the slope of the tangent line at the point x equals 1. So the first thing that we have to do for a tangent line slope is to find the derivative. So we got to find the derivative of our function. So we're going to do 1 over, well, our x in this whole thing is all of this. So we're going to have x squared plus sine x, all of that, and then ln of our base, which is 9. But then we have to remember to actually take the derivative of this part that I have circled. So the derivative of that would be 2x plus cosine of x. And so that's your derivative. And now to find the slope at the point x equals 1, we're going to plug in a 1. And so we have 1, we're going to evaluate the derivative at 1. 1 over 1 squared is 1 plus sine of 1, and then the ln of 9, and then 2 times 1 is just 1 plus the cosine of 1. And so now you need your calculator to evaluate that, and I want you to plug it in and make sure that you get the same thing that I get. Now your calculator needs to be in radians in order to get this answer. Otherwise you're going to get 1.3 something. But you should get 0.6278. And so it said approximate, and we are approximating. We're not trying to find the actual number. We approximated it as 0.6278. Okay, so that would be finding the slope of the tangent line for that graph. Now we're going to look here. We want to find the derivative of the absolute value of f of x. These tend to be a little bit harder for people to figure out just because you have to deal with piecewise functions. But I think after you practice them a little bit, you'll get more comfortable with them. So we have y equals the absolute value of x plus 2. So we want to graph this. If we graph it, it's going to look like a V. And it's going to be starting at -2. And we can set this up using 3 pieces. I'm going to color them so that you can see them a little bit better. We've got this one here, which is the equation of the line -x minus 2. And that's if your x is less than -2. Okay. If you continue it, it would keep going down, and it's going to cross at -2. And it has a slope of -1. Now this one is a second piece. It has the form of x plus 2. And that's if your x is greater than negative 2. And then we've got one more little piece we have to deal with when x equals 2. So if x equals 2, what is our y value there? It's just a 0. And so those are the three pieces that you're going to have for your function. And so now we're going to take the derivative of this. And basically what you're going to do is take the derivative of each part. So what is the derivative of x plus 2? 1. So the derivative is 1 if x is greater than negative 2. Now, the derivative of 0 does not exist. So if x equals 2, the derivative does not exist. Remember, at a sharp point, we do not have a derivative. So our derivative doesn't actually exist there. And then the derivative of negative x minus 2 is negative 1. So if x is less than negative 2, that would be our derivative. And so this is actually your whole answer. And so that's the part that people have a little bit of trouble with, trying to come up with these three pieces or two pieces to the graph, and then finding what the derivative isn't so bad, but it's that whole first step of figuring out what those three functions are. So I think looking at the graph is helpful, but some people can do it without looking at the graph. So whatever is easiest for you is fine with me. So let's look at this one. We've got an absolute value, and we also have a radical. So this is going to be graphed like this. This is negative 4, and this is 4. I'm sorry, the square root of 4, 2, and negative 2. If you didn't have absolute values, it would still look the same because the radical is always going to be positive. So you can really make this function just the square root of x minus 4 if you would like. So we're going to set up our function as 3, 2, 1. We're going to have a couple of pieces. On this one, we're again going to have 3. If you notice, in between negative 2 and 2, we don't have any part of our graph. So y is not defined. If negative 2 is less than x is less than 2. In between negative 2 and 2, we do not actually have a function. And then it's just x squared minus 4 if x is greater than or equal to negative 2. And then it's the square root of x squared minus 4 if x is less than or equal to negative 2. So now we just take the derivative of each part. And if you notice, since this function and this function are the same, we can take the derivative of it. We would have 1/2 and then x squared minus 4 to the negative 1/2 and then times 2x. And you can write it if x is greater than negative 2, x is less than negative 2. So if x is greater than 2 and x is less than negative 2. You can also write that as if the absolute value of x is greater than or equal to 2. So you could do it like that. Either one would be fine with me. And then y is not defined if you have negative 2 less than x less than 2. And so all of that would be your derivative there. Okay, let's look at one more. We have a function, and we're going to graph it. You've graphed these already this year. It's a parabola, and it would have looked like this. Well, that's not a great parabola. But it doesn't look quite like this because we've got the absolute values around it. Everything below the x-axis gets flipped to the top. And so this is a -2 and a 2. So the part that the absolute value did not affect is the part here and here. And so those functions can be written as just x squared minus 4. And that's when x is less than or equal to -2. Well, technically just less than -2. And then when x is greater than 2. And then the part in between is the part that was affected by the absolute value. And so that would be your piece, and that would be if, whoops, -2 is less than x is less than 2. And then we are forgetting one little part. Does anybody know what part we're forgetting? We got to have right here and right here. So I'm just going to write them down here. So if x equals -2 or x equals +2, it equals 0. So those are the pieces that we have for this function. And so now we need to take the derivative. This function and this function are the same. The derivative of those would be 2x. And we can actually write it if, instead of saying x is greater than 2 and x is less than -2, we can just say if the absolute value is greater than 2. So that's probably how you'll see it instead of having it split as these separate two pieces. Okay, now looking at the blue one, the derivative of that would be -2x. And that's if x is in between -2 and 2, which can also be written as the absolute value of x is less than 2. So you can write it either way. And then the last part we have, the derivative of the 0 is actually does not exist, because remember, we can't take the derivative at those two sharp points. So we have a does not exist, and that's if x equals -2 or 2, but you can also write that as just the absolute value of x equals 2. And so by using absolute values, it kind of shortens what you have to write, but I'm fine if you want to write it out a little bit more. So that would be the derivative there. So hopefully, as you practice derivatives of absolute values, it'll become a little bit more comfortable for you. But that's how you do those. You just make sure you memorize the formulas for the derivative of a to the x, and then the derivative of log base a of x. You do get to omit number 7 and number 12 on your homework, so make sure that you do that tonight so that we can go over it tomorrow.